Hello guys, welcome to Freebird's Crew and welcome to our new playlist of machine learning algorithms. So in this playlist I will tell you about the top machine learning algorithms that are used in data science, machine learning, and these algorithms are important from the perspective of interviews and the industry perspective. So be with it and learn every algorithms, and also I will tell you about the maths behind each algorithm so that it will easy to learn for you. So let's start our first video. That is, what is machine learning? So before starting that topic, I will tell you about the list of the algorithms that I will have in this whole playlist. The first is regression algorithms, decision trees, SVM, naive Bayes, KNN, k-means, random forest, and dimensional reduction. Also the gradient boosting algorithms. So these all algorithms I will choose and explain in this of my playlist. So machine learning is basically the logical approach to mimic the human abilities, because whenever a machine mimics the human abilities, it learns and understands automatically. It is an application of AI that learns with experience without human intervention. This can only be done using the data from which the system learns. So basically machine learning is of three types. The first is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is the learning when system learns from the labeled data. All the algorithms come under supervised learning consist of a dependent variable which is going to be predicted on the basis of independent variables. For example, I will tell you about a machine learning scenario where you have to predict the price of a house on the basis of the features of the house, just like its interior, exterior, area, location, all the things you are given. So these all the things are the independent variables, and our target or dependent variable is the price. So this type of data is called the labeled data, because we know each column that what it specifies. So examples are regression algorithms, decision trees, random forest, KNN, logical regression. So these are the supervised learning algorithms. So other is unsupervised learning. This learning in which the system learns from the unlabeled data. So unlabeled data is that we do not know that what this column specifies. That we have a lot of columns there, about 100 to 200 columns are there, and we have to predict that what this data specifies and what is this data. So we will use unsupervised learning here to just identify the pattern between the data. Patterns like we can categorize or segmentation of the data on the basis of various features. It's just like if we have a data, squares, circles, and rectangles, those pieces data, we have the features of those shapes. So whenever we categorize that data, it can categorize them into their respective segments. So all the square features are in the one segment, all the circle are in the one, and all the rectangle are in the one. So this is called segmentation. So examples are k-means clustering or aporia algorithm. So other is reinforcement learning. So reinforcement learning is basically when we used it for the decision making. So it takes decisions on the basis of the experience from the real world, because whenever a reinforcement learning algorithm interact with the real world, it learns by using the hit and trial method, that if it takes a decision good, it will get a reward and it will go to one step further. If it will take a decision bad, then it will get a punishment, it will go one step lower. So in this way the system learns from the experience and going towards the reward line. So examples are Markov decision process. So basically this is all in this video, that is machine learning. So in our next video I will tell you about the regression algorithms, that what is regression analysis, what basically is the regression. So hey guys, thank you so much. So in this video I will tell you about the regression algorithms. So regression algorithms are basically used to explain the relationship between the set of independent and the dependent variable. And independent variables are those variables on the basis of which the analysis should be done, and the dependent variable or the target variable is the variable which is going to be predicted. So regression analysis works on a equation like a mathematical equation which has the coefficients of regression and that told us about the relationship between those independent and the dependent variable. So before going into the mathematical section, we have to just know that which are those cases or which are those scenarios where we use the regression algorithms. So those use cases are when we have multiple independent variable and one target variable, when we have continuous and categorical variables, and when we have polynomial terms in model curvature, or access the interaction terms to determine the effect of one independent variable on the other variable. So these are some use cases where we can apply the regression algorithms. I hope you guys clear from this part. And now our next section is the linear regression. So linear regression is the simplest regression in the machine learning algorithms. If you guys understand this algorithms, all other algorithms are very easy to understand, because it is the base of machine learning algorithms. So its main focus is just to determine the relationship between the independent variable or target variable, or just like you can dependent variable. So if there is only one independent variable, then it is called univariate linear regression, and if there are multiple independent variables, then it is called multilinear regression. So these are the terms that I clarify here, and we can make a program on that in our going further video. So as you see that here is the graph that has blue data points. So these blue data points are the actual data, and this red line is our regression line that going past through these data points and going to predict the next value. So in this way we can plot our regression line with regression data to check the correlation, to check the relationship between those variables. So let's go into the mathematical foundation, because if you guys understand this mathematical foundation, it will go very easy to understand the whole linear regression mathematical part. So let's just say we have a target variable y which has set of independent variables x and up to n, because there are n number of independent variables, because as you see that there are n number of blue dots are here. So these n number of blue dots are our independent variables. So the linear equation of x and y becomes like this. As you guys see this linear equation, it should be goes similar to our linear equation of a line, as I show you guys here, that you guys are very much comfortable with this equation. Y is equal to mx plus c. So here we can see m is the slope of line, c is the intercept, and x is the value of x, and y is the value of y which is going to be predicted, which is going to be calculated. So here we can just see these two equations are very much similar to each other, but there is at last there is a error. That error is the difference between the actual value and the predicted value. So we can got this equation which is similar to this, and so we have to just find this coefficient regressions like b0, b1 and b2. So these are called the regression coefficients. So here the linear regression estimate those regression coefficients b0, b1 up to bn, and this should be written as like this without the error. So now you guys are very much comfortable about this linear equation which is going to be predicted, and if there is just one variable. So guys, you can just understand this. If there is just if it is a univariate linear regression, then the equation goes y is equal to mx plus c. That's it, because there is just one independent variable, that is x, and when there are multiple independent variable, then it will go to y is equal to m1 x1 plus m2 x2 plus c. So it goes like this. We just have to increment those our m and x values when they are more independent variables are there. So to predict our y value for each independent variable. For each x, we have to go for the function xk. For k is for every value from 1 to n, and this is very similar to the actual value yk. So now we got the error here. If there is something error, like if we are going to predict for f25 and we got value of 6.25, so there is a difference between 6.25 minus 5, and that difference is the error. So we are going to use this same equation here, that yk is the actual values and fxk is the predicted values, and the difference between both of them is the error. So to reduce these errors up to a minimum value, we are using a mathematical term that is called ordinary least square method. This method is used to minimize the error by squaring those errors and summation of them. So as you see the formula here, it is just summation of every error to the square of it. So for each value of 1 to n, it is going to be analyze and minimize those error up to a less extent and give us the best weights. The best weights means it will give us the best values of m and c. It will give us the best values of m and c, so that the error should be minimum. And so there is another point called coefficient of determination. Coefficient of determination, it states the amount of variation in y can be explained by its dependence on the variable x. Means if we just change a slight value in the x, it will going to be change also happen in the y. So this all the things is the coefficient of determination. When we got a larger value of coefficient of determination r square, that means our model is best fit for that data, or our predicted weights are the best weights for those equation. And if r square is equal to 1, it correspond to 0 error, and it's a perfect fit model. And now we are going for the simple or univariate linear regression. I hope you guys understand until like here that the mathematical concept. If you guys have any doubts, please put in the comment section. I will happy to answer all that. So let's start with the simple univariate linear regression. So simple univariate linear regression is just the regression where there is only one independent variable and one dependent variable. It's just like we have the location of house and we have the price. So these two are our this location of the house is the independent variable, this is the dependent variable. On the basis of house, we are going to predict the price. So this is the scenario that I will going to explain here. So the actual responses are these green dots, and the predicted responses are these red dots, and the estimated line, regression line, is this black line, with this dashed line is the residual error. So real values here, that is xy pairs, these are the real values or observations of k. So our object is to get the best predicted weights, that is b0, b1 or m and c, slope or intercept. We got the best values for these two. So to get the best value of these two, we are going to just draw an equation of line that I will show you here, that if we have only one independent variable, that equation is going to be like this, and here it is like this. It is very similar, it's totally similar, that here b0 is the intercept and b1 is the slope. So the calculation or to minimize the residual error so that we can get the perfect estimated regression function. So to go for that, we are going to with the equation of line, and we got our b0 called intercept and b1 called the slope. So with the help of those, we can easily get our function of line and the residual errors. So our next thing is, when we are going to calculate the slope or intercept, that is just the mathematical formula here show you in our programming part, that how to calculate the slope and intercept. So our basic point here is to just check that our residual error should be minimum, and we use our OLS part here. Then there is a note here that the p-values, when you are going for totally a mathematical part or in the statistics part, there is always a value called p-value. That p-value helps you to determine that the relationship you observe in your sample data also gonna exist in the larger population. The p-value for each independent variable test the null hypothesis that variable has no correlation with the dependent variable. So if the p-value is less than 0.05, it is statistically significant. It is the strong evidence against the null hypothesis. And if p-value is greater than 0.05, it is not statistically significant. It indicates the strong evidence for the null hypothesis. So this is going to be the most mathematical part or in the analysis part. So let's go for the implementation part here, that is from scratch implementation part. As you go to see here that to calculate the intercept, to calculate the slope, we are going to just calculate the mean of x and mean of y. When we going to calculate the mean of x and mean of y, we are just putting it into the formula to get the slope and intercept. The formula to get the slope of intercept is the summation of summation of y into x minus the number of observations into mean of x and into mean of y. So this is all the formula that is mathematically used. You can just remember it or write it down here, that we can get those values by doing that here. So in this way we can get the values of b0 and b1 on the basis of your data points. So now we get the plot regression. So we can just simply plot our x and y points here, and then we are going to predict our value using the simplest method, that is slope into x points and plus intercept. And we can also plot this line, and we can also plot the data points of the predicted value also. And also we can got the labels, and then we can got the main function. This is our arrays. You can going to see that this is one dimensional array. So this is just a single independent variable and single dependent variable, and we are gonna call our estimated coefficients here. It will give us the values of b, that is intercept and slope, and we can got the regression line here, and this is our regression plot. So you see that these purple points are the actual data points. These red points are the predicted points, and this green line is our regression line. So as you see that this is our regression line which is going to be predicted. For to just going not into this scratch implementation part, we can also use our libraries part here, that this is the libraries part that we are going to use here, that stats library. The stats library has a inbuilt function that is called linear regress, which is going to give us a very much useful information about the linear regression, that is the slope, intercept, r value, p value, standard errors, all the things it will going to give us. And similarly we got the function is like this, all the functions is like this, and we will go to just map each our value to the x so that we can get our predicted values and the actual values mapping to each other. So with the help of that, we are going to predict our predicted values, coefficient of determination, p values, r, slope, intercept, all are going value to be here. So this is the actual values, this is the regression line, and these are the other values which are going to be here. As you see that coefficient of determination is in the negative value, so it is not a perfect fit model for our regression line, though that means we need more data to make it up to close to 1. So, and here we can just use the same function to predict the value. I got to predict the value of 12 so that I give it x and it will return us the y. So if I going to give us 12, so for 12 it will predict the value for 82, means up to on this line here. So similarly, I can also use the sklearn library linear regression model here with just one dimensional array. That means this is only one independent variable and one dependent variable here. And similarly, I can just call for the model and fit my values of x and y and get the scores according to that. And all the values I can get from its model. So here you can see these are all the values that are going to be get from this model. So I hope you guys like this section of linear regression, and in our next video I will tell you about the multi-linear regression where we have more than one independent variables. Like here we have just only one dependent variable. In our multiple linear regression they are going to be more than one independent variables. So thank you so much. So in this video I will tell you about the multi-linear regression algorithm. So the multi-linear regression algorithm is basically the simplest form of the machine learning algorithms, where we just have to move one step ahead from the simple univariate linear regression. Because as you know, in the linear regression we have only one independent variable, but in multi-linear regression we have multiple independent variables and one target variable. So the equation that we form in the simple linear regression is this, that y is equal to mx plus c. But in multi-linear regression we make an equation that goes like this, is equal to m1 x1 plus m2 x2 plus c. So in this form the multi-linear regression will go, because we have more than one independent variable. So this equation as we have here, and we have to just simply go in the form of this equation. So we have the linear regression model is here. So this is the multilinear because we have more than one independent variable. As we see in our simple linear regression, we have just one value in x. As you see here, just a minute. So as you see here, we have just only one dimensional array is here for x, but in multilinear regression we have a two-dimensional array with the two values. So this is the multiple independent variables or multiple columns here, that one column value has 0, 5, 15, 25, another column value has 1, 1, 2, 5, 11, just like that. So we can just simply call our linear regression model here, and we can just calculate the values here. So and also predict the values like this. So basically this multiple linear regression model is just a one step ahead of the simple linear regression model. So just the difference is only in the values of x, that there are multiple column values and there are just only one dimensional values. That's it. Okay guys, so in our next video I will tell you about the polynomial regression. So polynomial regression is just about the degrees of the equation. So I will tell you in the next video. So this is our next video, and in which I will tell you about the polynomial regression. So basically a polynomial expression or equation is an equation that consists of the variables and along with the coefficients. And here the difference between a simple equation or a polynomial equation is just like the number of highest degrees you have in that equation. It's just like you see here. A polynomial regression is another type of linear regression that includes the linear term. Linear term means which are going only in the both ways, like I have shown you here. Like this is the linear term. But if I will have this polynomial regression with linear term along with its non-linear terms, which are going not in the linear, which are going not in a straight line. So the combination of both linear terms, a straight line terms, or the non-linear terms not in a straight line terms are called polynomial regression function. So for example, just like we take a degree 2 polynomial regression function. Degree 2 means the highest degree of a variable here is x square, so there is 2 degree. So this is our degree 2 equation, and so here just we need to calculate the regression coefficients, and those are b0, b1 and b2, which minimize the OLS. We have to find the best regression coefficients due to which the OLS is minimum. So let's compare it with the degree 1. Degree 1 means where the highest degree is x, no square, no cube. So here you got x1 and x2 is, this is the degree 1 equation. This is degree 2 equation because here x has square, here x has nothing, just 1. And now so these two equations are quite similar because in both the equations we need to find only the terms b0, b1 and b2. So solution is to solve the polynomial regression problem is just like same as the linear regression, but we use x square as a input variable, because as you see in our linear regression we use x as a function, because there is always a degree 1 equations, but in polynomial regression there is a degree that you have to find first and then apply those degree in your regression function. So here we will going toward this with the degree 2 equation. So I will take x square as my input variable. So in case of degree 2 means there are two variables, and hence we got the equation like this. So the procedure is same as the linear equation. We just have to apply that one of the 5 inputs, as in inputs are here x1, x2, x1 square, x2 square, x1, x2, and you can see this is just like a equation of a plus b whole square, that equation. And we got the result of our weights like b0, b1, b2, b3, b4, b5, and that decides the OLS. So this is the whole mathematics behind the polynomial regression that makes it different from the linear regression. I hope you guys understand the total basic mathematics behind it, and now we are going towards its programming part. So here you see that I just import the sklearn from here, and I got the polynomial features from here that decides the degree of equation, and that also decides the biasness in the equation. And I got the linear regression function here, and I got the array, and I reshape into the one dimensional, and then I got my target variable array, and then print both, and then I got the transformer, and I just put it as a degree 2 that exclude the biasness. Exclude biasness means there is no column with ones, and other function is just I have to just fit my x values in the transformer, and then I just got the x square, and the x square is got like this, and then I have to put this equation into our linear regression function, and I got our model with the result. So as you guys see, I got here the x square. So that x square gives me the value of the degree 2 equation, and when I put this degree 2 equation value into our linear regression model, it just behave like simple as it is a linear regression. There is just one additional step, is this: we have to just took x as a x square in this equation because of its polynomial degree 2, and we got our all other things like this. And other thing is, if we include the biasness, because you see here we just exclude the biasness, but if we include the biasness, we got this one values here, just a column with only ones, that is called biasness. And with the help of that, we just have to do the same things that we do above. We got our x square, we put this x square into our linear regression model, and we got the values. So you guys just play around this and can get the different kind of values from here. And you see that here the intercept is 0 in case of the biasness is true, but in case of the biasness is false, the intercept is there. So you just play around with this things, and you can get the your correct model and correct weights. Here you can also can predict these values like this, like I have to predict for the x square and get all the values are here. And here is the polynomial regression for multiple features, like I told you in the multiple linear regression. And so there are multiple columns here, multiple independent variables here. So here we also have the multiple independent variables, because as you see that this equation contains 2 independent variables and 1 dependent variable. So we just have to repeat the same process here, that we can convert it into the NP array and then call our polynomial transformation with its degree, and then biasness to fit transform, and then got this value into our linear regression model, and we can get our model result. And with the help of that, we get our all the values here, and our answers are here. So I hope you guys understand all about this, and because this is just basically the most easiest way to implement polynomial regression in Python. So in this video I will tell you about the underfitting and overfitting of polynomial regression algorithms. So basically the underfitting and overfitting occurs when we do not decide the correct optimal degree for the polynomial regression equation, because as we know that there are many degrees that you can decide for the polynomial regression as per your understanding of the data. But there are some conditions that we know that we are not trying to overfit or underfit our model. We just need the correct degree so that our model will predict up to its maximum accuracy on old data as well as the new data. So underfitting occurs when a model can't accurately capture the dependencies among data, usually as the consequences of its own simplicity. Because when the model is in underfitting state, it does not work well on its known data as well as its unknown data. It does not work well on any of that data, and it will yield the lowest R-square value. So that is the underfit condition. But the overfit condition is occurs when the model learns both the dependencies amongst the data and also the random fluctuations. So it means like your model will work very well on the known data. It will predict accurately 100% value on the known data. But when you give it a new data, your model fails. It does not get the correct thing when the data is new and your R-square value is very low. So these are the conditions where you need to give the optimal degree to a polynomial equation. So here are some graphs that will show you that. You see here we choose the degree 1 and the r square value is very low. So you see that this is the underfit condition, and here the r square value is 2 and here the degree is 2 and the r square value is 0.77, and you see that our regression line is basically very good. It means it is not underfit, it is not overfit, it is doing good. And here we see that our degree is 3 and r square value increases. That model just start doing the overfitting thing, but it is not correctly overfit yet, but it is little bit of overfit here. And here we choose the degree 5 and the r square value is 1. It is just say your model is perfect, but no model is perfect. You just have to pick up the right value, and here you see that it will go through the each value of the known data, but as soon as you give it the new data, it will crash. It does not give you the correct output because the model is overfit. So I hope you guys understand the concept of underfit and overfitting of the polynomial regression model. Thank you guys, thank you so much, in which I will tell you about the decision tree algorithms. So let's start the video. So basically, decision tree algorithms are supervised learning algorithms that are used for classification as well as regression cases, because they worked on both type of data, categorical data and continuous data. Categorical data means like you have the options like yes or no, true or false, boy or girl. So these type of data are called categorical data. But the continuous data is that contain many values or that contain many columns. So that type of data is continuous data that is basically used in the regression cases. So tree based algorithms are used because they empower the predictive models with high accuracy, stability and ease of interpretation, because they are easy to implement and easy to visualize. So they're also used because they are easy to implement the non-linear relationships, because that are very hard to implement in the linear models, but they can be easily implemented in the using decision tree algorithms. So now I will tell you about the basic working of the decision tree algorithms. So in this technique that we split the population or sample into two homogeneous sets based on the most significant splitter in input variable. That means we have to split a part of our whole data into a sample, and we have to perform all our techniques or functions on that sample that will tell you about which decision is best. So in overall way, decision trees helps you to take the best decision. Like here we have a diagram here that whether we play or not. So it depends on the various conditions that we give here. Then the outside weather is sunny, overcast or rainy, that there is humidity or there is windy. So on these variables we have to decide whether we have to play or not. So this is the just basic technique that we have to play or not by using the decisions tree algorithms. So now I will tell you about the internal working. So internal working is just like that. It splits the best attribute using the attribute selection to split the record. Attribute selection measures, there are many selection measures in the decision tree algorithms like Gini, chi mean squared. There are many measures, but we have to just concentrate on the internal working here. We will discuss about its attribute measure in our next videos. So now it will make that attribute a decision node and break the dataset into the smaller subset. Then it start tree building by repeating the process for each child node until the condition will match. Like all the tuples belong to the same attribute value, there is no remaining attributes, there is no more instances. Like you see here, it will work like this. When you give it the data, it's split into the training and test. You can give the training data to the decision tree generation, and that all the process occurs here. It will select the best attribute using the ASM, and here are some of the ASMs like information gain, Gini index or gain ratio. These are the ASMs, and then it will break the data into the smaller parts, and it will continue repeating the process until it will reach to a position that we will give it. Like we tell our model that it will only go to the 5 nodes. So it will only go to the 5 nodes, and it will continuously split until the 5 node structure is observed. So as we see that using this technique, we got our model evaluation using the text data, and that will give us its performance measures like accuracy, precision, or recall. So in this way the decision tree works. So basically decision trees are of 2 types, as I will tell you above, that there is 2 types of data that it accepts: categorical data or continuous data. So categorical data means yes or no, true or false values. Like I will show you the scenario here: play or don't play. So this is the categorical data or categorical decision tree. So in continuous decision trees, we have continuous target variable. For example, I will show you the example here. Let's say we have to predict whether a customer will pay his renewal premium with an insurance company, yes or no. We have to predict yes or no, but our data is continuous. So here we know that the income of the customer is a significant variable, but insurance company does not have the income details of all the customers. Now we know this is important variable, then we can build a decision tree to predict income based on the occupation, product, and various other variables. In this case, we are predicting values for continuous variable. Like we have to predict the customer income first, and then we will decide he will pay or not. So I think you guys cleared about until this. Now I will tell you about some of the basic terminologies that are used in the decision trees. And as you see, this is the diagram that will easy to understand with this all terminologies. So first terminology is root node. It represents the entire population or sample, and thus further gets divided into its one or more homogeneous sets. And now the splitting part. Splitting part, it's a process to dividing a node into 2 or more subnodes. That means up to a condition. Then other part is decision node. When a subnode splits into further subnodes, then it is called decision node. Leaf node or terminal node. Node do not split is called leaf node. That is the last node of the decision tree. Pruning. Pruning is a process to improve our decision tree. So basically when we remove the subnode of a decision tree, it is called pruning. That is basically called, we have to just minimize the complexity of the decision tree to get better result or to avoid the overfitting. This is why pruning will used. I will explain the pruning, the overfitting concept, and how to prevent it, all other stuff in our next video. So basically the other thing is branch or subtree. A subsection of entire tree is called branch or subtree, as you see here in this image. And now the parent or the child node. A node which is divided into subnode is called the parent node of the subnodes, whereas subnodes are called child node. So you see that this root node is the parent node and all other nodes are the child node. Similarly here, these two terminal nodes are the child node, and this decision node is the parent node of these two nodes. So I hope you guys understand until this. So now I will tell you about the advantages and disadvantages of the decision tree. Just a minute. So now I will tell you about the advantages and disadvantages of the decision tree. The advantages means that it is easy to understand, useful for data exploration, less data cleaning required because it is not influenced by the outliers or missing values. Because as we see in our linear models, they are easily get influenced by the outliers. Means if there is a values like 1, 2, 3, 4, 5 and there is suddenly a big value comes in like 1000 or 1 lakh, so that is a outlier, and due to which our whole linear model accuracy will affect. And the other thing is data type is not constrained because it can handle both the numerical data, both the categorical data, and it is non-parametric in nature because we do not have to specify some kind of parameters in there. If we do not specify the parameters, it will work very fine. And the disadvantages are overfitting and not good fit for continuous variables. Means like if there are continuous variables in a very huge amount, like there are thousands of continuous variables are there, and then we have to split the data on the basis of that, so that is kind of hard, or the accuracy will less. So that's all in this video. In our next video I will tell you about the difference between regression or classification trees of decision trees, and this is the next part in the decision trees algorithms part. So in this video I will tell you about the difference between regression trees and classification trees. As we know that the terminal nodes are lies at the bottom of the decision trees, because I will explain the terminologies in the last video. You can check on the I button here. And this means that decision trees are basically draws from the bottom to up, as bottom part contains the leaves, upper part contains the roots. As you see this image, this image is the perfect example of the decision tree or classification trees example. As you see that the leaves are below and the roots are above. And so here is the difference between regression trees and classification trees, and some also similarities are also here. So as you see that, I will just tell a little bit. So here, so regression trees are used when dependent variable is continuous. Classification trees are used when dependent variable is categorical. The values obtained by terminal nodes in the training data is mean response of observation falling in that region. Thus, if an unseen data observation falls in that region, we will make it prediction with mean value. And in the classification part, the value obtained by terminal nodes in the training data is the mode of the observation. As you see that in regression tree it is the mean, but in classification trees it is the mode of the observations falling in that region. Thus, the unseen data observation falls in that region, we will make its prediction using the mode value. In the regression trees we using the mean value, in classification trees we using the mode value. And trees divides the parameter space like independent variable into distinct and non-overlapping regions. Like it divides the trees into distinct and non-overlapping regions. But the classification trees are also do the same thing. It also divides the independent variable into the distinct and non-overlapping regions. And this follows the top-down greedy approach known as recursive binary splitting, and this also follows the greedy approach top-down as recursive binary splitting. This splitting process is continuous until a user defined stopping criteria is reached, like how much roots they want, 4, 5. When the criteria is reached, the tree will stop. And the splitting process is continued until a user defined stop criteria is reached. Similarly, and the splitting process results in a fully grown tree until the stop criteria is reached, but the fully grown tree is likely to overfit, because when we do not define the ending criteria very well, like if we want that our model will go to all of its node, all of its data, then our model will surely overfit. So this can be prevented by using the pruning technique, and this is same for the classification trees. I hope you guys clear the difference between the classification trees and regression trees very well. In our next video I will tell you about that how decision trees are decide from where to split and how to split. Like this is the most interesting topic in decision trees, that how they think that this is our splitting point or from where we need to split that data. So we will meet in our next video, in which I will tell you about how tree-based algorithms decide from where to split. That it is very kind of interesting topic, that how tree-based algorithms knows that this is the point where we have to split, or this is the best point from where we have to split and get the best accuracy. So this is kind of very interesting topic here. So split path is basically affects the accuracy, but decision criteria is different for both the regression and classification trees. It uses multiple algorithms on the basis of target variable to decide from where to split a node into two or more subnodes, and creation of more subnode increase the homogeneity of the subnodes. So as you see that it basically use multiple algorithms here that decide that this is the point where we have to split and get the best accuracy. So decision tree split the nodes on all available variables and then select most homogeneous subnode split. Like it split the nodes on all the available variables and then select the most homogeneous subnodes to split, like most similar subnodes to split. Purity of the nodes increases with respect to the target variables. So these are the four algorithms that are used in decision trees to split, like Gini, chi-square, information gain, or reduction in variance. So these algorithms are basically have their mathematical explanation behind them, that using that they have to split that data. If you want to know more, you can contact me on my Instagram account, or you can just comment it down. I will explain each algorithm in separate videos, or in our next video I will tell you about the key parameters that are used in the tree-based algorithms that decide your model's accuracy. So these key parameters are very much of used to avoid the overfitting. So be with it and watch our next video for sure.